Well, hello. Today's video is on Doppler's effect. It's a small video, very interesting concept in continuation with the methods we saw in the last video regarding how to measure the distance of the distant stars. We did parallax method and standard candle method. So this is another method which has helped us to find that different galaxies, different stars are moving with high speed and they're also moving far away from us. Okay, first let's come back to Earth before going to space. What is Doppler's effect? This effect was first discovered in sound. We all know sound is a wave, and it was very clearly understood how it is observed in the sound waves, and then it was applied to the light waves, and then it was discovered that the galaxies and the stars are moving away from each other, proving that universe is expanding. All right, so let's just get started. On the first side, there you can see two animations here. So if you see the first one, this one here, okay, I can't see my pen, I can. So this one, if you see, the source is emitting some kind of wave which is 800 hertz. Okay, so this one, just give me a second. Yeah, so this is 800 hertz, and the observer who's listening to the siren sound made by the ambulance, and he's also finding the frequency to be 800 hertz. I practiced this with my son yesterday, and he was making a sound and moving his head, and I really experienced a change in his frequency. His voice seemed sharper when he was moving his head towards me, and when he was moving his head away from me, his voice was appearing less sharp. You can try this with your friend too. So anyways, so if a source is stationary, whatever frequency it is emitting, the observer finds the same frequency. There's no change in the frequency. But if the source is moving, as you can see in the second video, the source is moving towards the observer, the waves get bunched up. So this bunching up shows that the frequency has increased. So the frequency which is perceived by this observer has increased. So that's why it's called apparent frequency. It's not the actual frequency. It is still emitting probably 800 hertz, but the observer, the frequency that is received by the observer is more than 800, as you can see the bunched up of the waves here. So Doppler's effect is nothing but apparent change in the frequency. I'm going to write it somewhere. Let's just write it here. So apparent means it's not an actual change, but it appears to the observer. So apparent change in frequency. Now what is the cause of this apparent change? Okay, let me go back to the second slide. On the first is there's no apparent change in the frequency in this case. Why is that? It's because both the observer and the source are stationary. So what's the cause of Doppler's effect? What is Doppler's effect? Apparent change in frequency. And what is the cause of Doppler's effect? Because of relative motion between observer and source. Between source and observer. Okay, now, so if something comes closer, wait, I'm just going to add one more slide so that I can explain you the stuff. So if something is coming closer, the frequency of that source increases. For example, I'm standing here and a source is coming closer. So if it is emitting a frequency of 10 hertz, I will end up hearing frequency greater than 10 hertz. I will not hear 10 hertz. If the source starts moving away from me, 10 hertz still, case 1, case 2, I'll end up hearing frequency which is less than 10 hertz. That is Doppler's effect. apparent change in the frequency because of the relative motion. Whereas if the source is stationary, it's not moving, and it is emitting f equals to 10 hertz, I'll hear the same frequency. No change. So this change happens only when there is a relative motion between the source and the observer. Now, because we know that wave speed is frequency times wavelength, and this is the speed of sound or the speed of light wave, electromagnetic wave, this is constant. If the medium is not changing, the speed of the wave is constant. So the speed at which the wave is traveling towards me, that speed is constant. So if the frequency appears to have increased, what would happen to the wavelength? It would decrease. Okay, so when something is coming towards me, the frequency would appear to increase, wavelength would appear to decrease. Inverse relationship. Why inverse relationship? Because their product has to remain constant, the speed has to remain constant. So if something is going away, wavelength increases. Okay, now in the case of light, if you remember from electromagnetic spectrum, the violet color, okay, the violet color has minimum wavelength, or the blue color has minimum wavelength, whereas if you go from ultraviolet to infrared, the red has maximum wavelength. So if you are originally seeing something as violet and then it starts moving away from you and you eventually see it as red color, that means that thing is going away from you. That's why its color is now appearing as red. So that is the Doppler's effect in light waves. Now, okay, now just see, focus on, this is a source, okay, source of light is at the center. Now see this observer and this observer. For the man or the boy, the wave is going away, the source is going away. So see how the color changes. It is changing from blue to red. Now for this lady here, the source is moving towards the lady, the color is changing from red to blue. So when the source is moving away, light source moves away, okay, that's let's say a star, it is moving away from Earth, what kind of color change would happen? It'll shift towards red, so that is called red shift. This is the change in the color or the wavelength. Now for if the light source is moving towards, okay, as for example for the girl, okay, light source is moving towards, what would happen? See, it was appearing red and then it shifted to which color? Blue shift. Now how do we know that the universe is expanding? Every single light ray coming from galaxies or stars over the years is found to be red shifted. Because it is red shifting, we know that the universe is expanding. All right, let's just do some multiple choice questions. Pause and check your answer. This dot, I don't know why this dot is appearing here. That's not the right answer. Okay. The Doppler's effect refers to what? It does not refer to, okay, I am hoping you've already paused and done it. So it does not refer to change in amplitude. It refers to the apparent change in frequency or wavelength due to relative motion between source and observer. That's it. What is Doppler's effect? Apparent change in frequency or wavelength. Why does it happen? Because of relative motion between source and observer. A source moves towards a stationary observer, fine. What does the observer notice? So if a source is coming towards you, the frequency would increase and wavelength would decrease. It would be blue shifted. Oops. So it would be the second one. Always pause before you check answers with me. Now the redshift. As I've already explained you, if something or a star or a galaxy is moving away from, this is what the data we have received. This video is actually from the site of NASA. So this is what actually happens. We're observing a star or a galaxy today, and if it is blue in color today, after some years its color would change to red. That means that a star or galaxy is shifting away from us because it is red shifting. Now this is, so what is the cause? How do we know that it is moving away from each other, from us? Because red shifting. Why is it red shifting happening? Because the wavelength is becoming higher than the original. The apparent wavelength is higher than the rest wavelength. If the star would have been at the rest here, if we receive, let's say, lambda rest, when it starts moving away from us, we do not get this wavelength, we get some apparent or observed wavelength. And because observed wavelength is greater than the rest wavelength, whenever the wavelength increases, what do we call? We call it as redshift by Doppler's effect. And because a redshift has happened, that means the star is moving away from us. See, okay. Now this relationship, the ratio of difference in wavelength over original wavelength, is called redshift. So how did I get del lambda? Del lambda is the difference in wavelength, which is observed wavelength minus rest wavelength divided by rest. This is a common mistake. You do not divide it by the observed, you divide it by the rest. If your z is positive, what does that shows? That the observed wavelength is higher. So when the observed wavelength is higher, what does that mean? That means the star or whatever galaxy you're observing is going away from us. Now also we can calculate if the velocity of the galaxy or the star is low. This is also one of the relationship that is again part of the A-level physics. So V over C, where C is the speed of light, almost 3 times 10 to the power 8 meters per second, and V is the recessional velocity. Recessional means the velocity at which the star is receding from us. See, is it not? It's going away from us. So with what velocity is it going away from us? We can just calculate it by timesing it with Z. The condition is though that it should be low velocity, it should not be very high velocity. Okay. Let's do some question again. Pause and do it yourself before discussing with me. A star is moving away from Earth. All right, so it's going away. That means my lambda observed will be definitely greater than lambda rest. What is observed in its light? Increase in wavelength. Because it is increase in wavelength, what would happen to frequency? Decrease. Do not make a mistake. Not increase in frequency. It's increase in wavelength. And next one. Light from a distant galaxy is observed to be redshifted. So if it's observed to be redshifted, that means the galaxy is going away from us. So definitely the first is not correct. Is away from Earth and wavelength has increased. That's it. Over and over the same thing. All right, now some calculation questions. Light from a distant galaxy has a wavelength. So this is the wavelength. So this is the rest wavelength. When emitted, the wavelength observed on Earth. So what's the wavelength that is observed on Earth is 720. So lambda observed is 720 nanometers. Calculate the redshift. So redshift is lambda observed minus lambda rest divided by lambda rest. Remember, you can convert it into meters here, but we don't need it because it's just a ratio. Okay, minus 656 divided by 656. Okay, even if I don't convert it into meters, does not matter because it's just a ratio. So let's calculate. So answer is 0.098. So my Z here is 0.098. Assuming Z is much less than 1. Yes, it is. We don't have to assume it. Estimate the recessional speed of the galaxy. So the recessional speed of the galaxy, how do you calculate it? So just use the formula. The formula was Z equals, so Z equals to V over C. So I can write V equals to ZC 0.098 times 3 times 10 to the power 8, or whatever is given in your equation sheet. Plug in the value and your answer is, just give me a second, answer is 2.94 10 to the power 7 meters per second. So it is almost moving at this much speed away from Earth. Right. Now again, you try it yourself first to get the answer. So calculate the redshift. So redshift is 721.6 minus 656 divided by 656. That gives me an answer of that is around 0.1. So this is giving me 0.1. No nanometers. Z is a pure number, it's just a ratio. Explain qualitatively what the redshift tells us about the galaxy's motion relative to Earth. So what does it tell you? Z is 0.1. Z is positive, isn't it? So if Z is positive, what does that mean? That observed wavelength is higher, or it's also given in the question. So you can just say the observed wavelength is higher than the rest wavelength, which means it is redshifted. Redshift means when does the redshift occurs? A redshift occurs when the light source is moving away from the observer. That means the galaxy is receding from the Earth. So we have tells us what is the redshift telling us sorry, about the galaxy's motion. So you can write because lambda observed is greater than lambda rest, redshift occurs and when does the redshift occurs? When source moves away from observer. I'm giving you a 3-mark answer. Source moves away, and that means the galaxy is receding away. Galaxy is receding away from Earth, related to Earth. That's it. Well, let's try this one. You try it first. A distant galaxy emits a spectral line normally observed at 500 nanometers. Astronomers detect this line at 525. They also notice that the light from the same galaxy appears slightly fainter than expected. Now, why the wavelength has changed, and suggest a reason why galaxy's light might appear dimmer. So that means you have to explain 2 things. You have to explain why the wavelength has changed and why it is appearing dimmer. So let's explain the first point first. Why the wavelength has changed. If the wavelength changes, if the wavelength increases, then you say that it is receding away. Now it's asking you why the wavelength has changed. So first, you will note, what did you notice? It is greater. So that's your first point. Observed wavelength is greater than, lambda observed is greater than the normal one. Okay, you can write in words. I'm just writing to decrease your screen time. Okay, so this has decreased. So the observed wavelength is increased. That means what? It's redshifted. So redshift. What does redshift means? it means galaxy is receding away. Okay, that's why the wavelength has changed. So receding away from Earth. So you explained the first point, why the wavelength has changed, and because of Doppler's effect, you can also write. So the wavelength changed because of the Doppler's effect. So lambda changed because of Doppler's effect. Now, they are interested in you writing this word Doppler's effect. You have to specify the word Doppler's effect. Now, why the galaxy's light might appear dimmer. Now, if it seemed like, okay, it's so obvious, but you just need to write that because the galaxy is receding away. As galaxy is receding away, the light spreads in a larger area. Okay, inverse square law, light spreads in a larger area. Larger space, not area, larger space, hence it appears dimmer. That's it. Okay, some of the questions would appear so obvious, but it's over and over the same thing. Why wavelength changes? Because of the Doppler's effect. Okay, if the wavelength has changed, so what does that mean? That means it must be receding away from Earth. If it would have given you a blue shift, that means that particular thing is coming closer to us, but that's not happening. We haven't seen anything that comes closer to us till date, so everything is relatively moving away from Earth, right? So that's all for this video. Keep revising, keep practicing. If you want to practice more question, you can practice from Merit Minds. Thank you so much.